So the next talk is entitled Scientific Motivation for Sample Return from SPA, and the talk will be given by Chip Shearer doing his very best Brad Jolliff impersonation.
Thanks, Lars. Brad apologizes for not being able to make it. He had a conflict in terms of meeting times and schedules. And so just a couple days ago, he downloaded, 17, 20 slides for me to squeeze into 10 to 12 minutes. So I edited a few out, but I'm going to try to just speak to all the slides that I left in the presentation. For this session, we're going to switch gears now. And this talk and the remaining two talks are going to focus upon the exploration portion of the title of the theme of this session. And again, this is a motivation, examining the science motivation for sample return from SPA, but also it's a change in direction in terms of where most of the talks have focused upon the geology of the moon and the origin of crustal lithologies. This again is going to look at both those, but in addition to really trying to use the moon as a recorder for examining other key early solar system events. And the one key event or hypothesis that is incorporated in the science of sample return from the SPA is really testing the late heavy bombardment hypothesis that was proposed in 1974, and it was based on the analysis from large, late, near-side basin samples. And ideally, SPA is the oldest and largest of all these basins, and may provide a fairly unique answer to test the late heavy bombardment model. In addition to this cataclysm, this has been coupled with the NESF model and other models that allow us to address, using and evaluating the late heavy bombardment, the orbital dynamics of the giant planets. And these types of approaches in using the moon as a recorder really hints, evaluating these processes, hence this sort of mission to sample the SPA has been noted in 2 decadal surveys, one because of its importance for the Earth, early life and habitability, the importance for the evolution of the inner solar system, understanding dynamics of the giant planets, and also perhaps even have applications for the dynamics of extrasolar planets. Why the SPA? One, again, this is the largest and oldest clearly recognizable impact basin on the moon, and as such, SPA anchors the lunar impact chronology. It provides us with the SPA formation completely resurfaced a huge area of the moon and probably reset ages. And with samples, we can determine the age of the basin and the chronology, perhaps, of other large impacts within the SPA. This is one of my favorite images of the SPA, which again shows the large size of the basin in terms of dimensions from the South Pole to the Aitken crater. And also, as you can see, this is a diagram that also illustrates the elevation and the depth of the SPA basin. What I'm hopefully going to do within the time limit that I have is touch on what we thought were important scientific problems that could be potentially solved with an SPA sample return. One, one can establish early solar system chronology, establish ages for early solar system events, and test dynamical models for the gaseous giants in the solar system and the giant planets. Also, this mission could provide or will provide detailed lunar history in terms of magmatic history events, impact environment events, and a new view of maybe lunar volcanism from a different portion of the moon. It also will provide us some evidence for crustal structure for this region of the moon, including the if the SPA impact melt or sea differentiated. It also allows us to evaluate giant impact processes, and at least close to my heart, it really allows us to look closely at basaltic volcanism from a different part of the moon and perhaps evaluate some of the mantle heterogeneities which may be different from some of the heterogeneities on the Earth-facing side of the moon. And so this allows us, if you remember Lars's talk in discussing the age of the lunar basalt, the lunar mafic cumulates, this allows us to get additional information tied to whether all the cumulates will reset, all the cumulates represent a lunar magma ocean event. In terms of early solar system impact chronology, and again, those science issues I'm going to step through one at a time. These are some of, as you can read on behind me, some of the importance for sampling the SPA in terms of spanning the range of SPA formation to the formation of some of the more younger craters and basins associated with the SPA in the region. Determination outside the Apollo lunar sampling region that was dominated by Imbrium. And also, again, as I want to emphasize, it's fundamental to testing early solar system dynamical models, such as the NESF and Grand TAC models for giant planet migration. And again, one of Bill Bodke's models for the hypothesis that pre-Nectarian impacts were related to a sweep up of late accretional or moon-forming giant impact debris. The testing of the cataclysm can be shown, at least in graphical terms shown here. And one is really essentially testing this gradual decline model, again shown in black here, and trying to distinguish that from this impact cataclysm driven by the migration of the giant gas giants shown right here. And so ideally the age of SPA will allow us to distinguish between those two. A SPA age in this range may allow us to conclude that a cataclysm actually did happen, where a older age may again allow us to conclude that this gradual decline is an appropriate model. With regards to lunar geological history, in terms of the magmatic history offered by a sample return to SPA, there are numerous questions illustrated behind me in terms of the magmatic history. Are the SPA rocks related to the magnesium sweet rocks, which Lars again spoke about and I spoke about to some degree, or one of the granulitic sweets that we see from the Apollo collection? What are the igneous rock class and SPA impact breccias? Was the SPA formation related to one of the igneous rock age spikes recorded in lunar samples? And then finally, what I inserted in here, because I was really fascinated again by David Kring's talk, is could SPA be a trigger for major near-side magmatic activity. I find that incredibly enticing, but I think once we date SPA, or that this will partially answer the question or allow us to investigate even more complex models. Crustal structure is another important facet of a sample return mission. What is the nature of the SPA material in the SPA? Does it represent melted lower crust or lower crust component? Does it represent mixtures of lower crust and mantle, or are there mantle components associated with the SPA terrain? Also, it allows us to look at perhaps the differentiation of a very, very large impact melt sheet. Samples, again, are needed to answer these questions. In addition, this allows us a sample return to explore giant impact processes, as shown in this slide, the depth of excavation, the obliquity of the impact of melt seed depth, how deep is this, could this impact melt sheet be, what the SPA ejecta and thickening of the northern highlands far side really mean. Is this additional ejecta of mantle material onto the highlands as suggested by Malash, I think a couple of years ago? And if that's true, does that really mean that the upper mantle is a slightly different composition than we had imagined? Also, with regards to impact debris, is there impact debris that we can identify, as Mark Wazorek had suggested, I think last year at LPSC? And is this have any relevance to the origin of the far side highlands versus the lowland, the near side lowlands dichotomy documented by Brad and numerous papers? Yeah, I've got it's just 2 more slides. Yeah, I think so. Also, as I mentioned, the volcanism SPA I find very important and perhaps very valuable in terms of better understanding the differentiation of the moon and the chronology of the moon in terms of timing and evolution, understanding the Mare versus the crypto-Mare, and perhaps sampling melts derived from the sub-SPA mantle, and testing, again, models for origin differentiation of the moon. In conclusion, this mission provides us with a lot of additional information concerning not only the evolution of the moon, but dynamical processes in the solar system. It may provide us with chronology. It certainly will provide us with lunar history, magma ocean differentiation, and subsequent volcanism, and again, as I mentioned, the giant impact processes. And all of this requires sample return and, again, integration of the whole team, not only the sample scientists, but everybody, the modeler, the people who do modeling, the people who do geology, those who do remote sensing, to better integrate all these results to better understand the samples and the event represented by the SPA. That's it. Yeah, Larry.
Yeah, Larry Taylor, University of Tennessee. Great talk. You're talking to the choir again.
Yeah.
But, you know, one thing that I've caught on that is really, and you caught it and brought it up there, the stuff with Pete Schultz and Dave Kring now, that whole thing, you could make that into a very huge story about the near side, far side, SPA being the trigger for that, okay? We know SPA is older, and so that could, I mean, and I can see that as being something new to add to your repertoire that you have for presentation. A big play on that sort of thing.
No, I think you're entirely right, Larry. And again, one is...
Can you use the microphone, please?
Use the mic. Oh, sorry. Sorry. It's a very testable model also in terms of the timing, the SBA, and potentially how it may impact lunar magnetism. Jeff?
Jeff Placia, APL. Suppose you get a date of 4.3 billion years for SPA. What does it tell you then about the chronology?
I think it will allow us to test, I think to some degree, that the cataclysm in terms of it occurring at 3.8 or 3.85 or 3.9 probably isn't correct.
But it would, I mean, it's the largest basin. You would expect it to be old.
Mm-hmm.
So it doesn't, I don't know that precludes there still being a cataclysm, even if you've got an...
Or it's a more extended cataclysm, right?
Yeah.
Very quickly, Barbara.
I just wanted to follow up on that. It's one of the major points is that it's far from Imbrium, and if one of our confounding points is that we see Imbrium over and over again, or may see Imbrium over and over again, then it's sort of a blank page for